today's lessons on writing polynomial equations given complex roots. So this goes back to something that we've done before in our class. When we're given x-intercepts, we'll be able to find the equation. So let's try this example here. Find the equation of the polynomial given the roots x equals 5 and x equals -1. Remember that the term roots is just another term for x-intercepts. And in this example, because we have two x-intercepts, this polynomial is going to be a quadratic function. And most of the ones that we're going to be doing will be quadratic functions. So what we did before would be we would write the equation, we would look for a, and we would write our x-intercepts, but we would flip the signs. Okay. And the reason why is because when we make it equal to 0, it actually changes signs. So in this example, like I said, we are not going to look for a. We're just going to find the equation. And to do that, we are going to distribute this out. So that will give me x squared plus 2x minus 5x minus 10. I can combine like terms. That gives me -3x minus 10. So this would be the equation if our x-intercepts were 5 and -2. So let's apply the complex roots as our answers. So let's try this one. Find the equation given the roots x equals 3 minus 2i and x equals 3 plus 2i. So just remember that complex numbers, their solutions, their roots, they always, no matter what, come in conjugate pairs. And we will talk about that a little bit later on. Again, they always come in pairs. So if you look at this right here, we have 3 minus 2i, and the conjugate will be 3 plus 2i. So let's find this equation. So again, we have x equals 3 minus 2i, x equals 3 plus 2i. Remember, we're not going to be looking for a, so we're just going to plug these x-intercepts into our equation. And remember, when we do that, we switch the sign, so that becomes -3 and positive 2i. Same thing here. If I switch it, it becomes -3 minus 2i. So again, we're switching the signs. That's what we're doing. So now I'm going to distribute this out. So I have to multiply the x to each one. So x times x will be x squared. X times -3 is -3x. X times -2i, I know when we have, a lot of times when we have two letters, people get a little confused, but they just stick together, and normally we write it in alphabetical order. So it'll be -2ix. Now I'm going to distribute the -3 to each one. -3 times x will be -3x. -3 times -3 is +9. -3 times -2i is +6i. And this is getting a little messy. So now I'm going to multiply the 2i to each one. So that would be plus 2ix. 2i times -3 is -6i. And 2i times -2i will be -4i squared. So it looks kind of long, but we can actually simplify and combine like terms. This is the only x squared we have, so I'm just going to bring that down. I have this 3x and this negative 3x, so that becomes negative 6x. This 2ix, negative 2ix, and this positive 2ix are going to cancel each other out. I have a positive 9 from here. This positive 6i and negative 6i are going to cancel each other out. And I'm left with this negative 4i squared. And if you remember from before, I squared equals negative 1. So I'm going to plug that into there. Bring everything else down. And I'm going to multiply this negative 4 and negative 1. That's going to become positive 4. I have the x squared. Going to bring down the negative 6x. Bring down the positive 9. And I can combine those two to be positive 13. So I get x squared minus 6x plus 13. And that is going to be our equation. So again, even though it looks a little messy, things will cancel out and you get a quadratic equation. Let's try another one. So again, these are conjugate pairs. And we're going to put it back into the equation and we're going to switch the signs. So now that is a negative 10, it's going to become positive 10. Since it was positive 4i, this becomes a negative 4i, and this one becomes a positive 4i. And now just distribute them out. So I get x squared plus 10x plus 4ix. Multiply the 10 to each one. So that's plus 10x plus 100 plus 40i. And now I'm going to multiply the 4i to each one. So that's negative 4ix minus 40i minus 16i squared. So again, I have only the x squared. This 10x and this 10x I can combine to be 20x. The 4ix and the negative 4ix are going to cancel. I have this plus 100. This 40i and this negative 40i are going to cancel. And I'm left with this negative 16i squared. But again, I squared is negative 1, so I'm going to plug that in. And this is going to be positive 16. So I have x squared plus 20x plus 100. And I can combine those two. So my answer be x squared plus 20x plus 116. Let's do one more. Well, as I mentioned before, complex solutions will always come with conjugate pairs. So that means automatically we will also have x equals 7 plus 3i. So let's plug that in. And since it's positive 7, it's going to be minus 7. And then we're going to have a positive 3i and a negative 3i because, again, we're switching the signs. So let's distribute this out. I get x squared minus 7x minus 3ix. Multiply 7 out. Negative 7x plus 49 plus 21i. And now multiply the 3i to each one. So plus 3ix minus 21i minus 9i squared. Again, things will cancel out. So I have my x squared. My negative 7x is combined to negative 14x. 3i'x's cancel out. 21i's cancel out. I'm left with plus 49 minus 9i squared. And I'm going to plug this in. So it becomes negative 9 times negative 1. So it becomes x squared minus 14x plus 49 plus 9. I can combine those two, so my answer is x squared minus 14x plus 58. So let's take a look at our answers and our equations so far. The first one that we had x equals 3 plus 2i and x equals 3 minus 2i. And this answer was x squared minus 6x plus 13. The second one we had was x equals negative 10 plus 4i and negative 10 minus 4i. And our answer here was x squared plus 20x plus 116. And our third one was x equals 7 minus 3i and 7 plus 3i. And our answer was x squared minus 14x plus 58. So some of you are probably wondering, is there a shortcut? Yes, there is. So if you look at the numbers in red, how is that number related to our solution? And then the last number also comes from something you have done before. So let's say I give you x equals 5 plus I and x equals 5 minus I. If you are able to figure out the shortcut, the answer will become y equals x squared minus 10x plus 26. So think about, where does this negative 10 comes from? How can I get a 26 from a 5 and a 1? Let's try one more. If I give you x equals 11 minus 2i and 11 plus 2i, I can tell you right away my answer is going to be y equals x squared minus 22x plus 125. So what is the shortcut? If you want to know the shortcut, you have to show up at our Zoom meeting. And that is the end of our lesson for today.